All right, this is lesson 26 on probability. So probability is the measure of how likely something will happen. So an event will occur. So the probability of an event, that's what P with the event inside means, equals the number of favorable outcomes over the total number of outcomes. So probability can be expressed as a decimal fraction or percent, but it's always between 0 and 1. Okay, so finding the probability of compound events, so P of A and B, so the probability of A and B is found by calculating the probability of all outcomes that are in both events. So for example 1, a spinner with 6 equal sections numbered 1 through 6 is spun 1 time. I want to know what the probability is that it lands on an odd number that is less than 4. So since there are 2 values, so 1, 2, 3, 4, 5, 6, odd number has half of those, so 1, 3, and 5, and then it's less than 4, so 1 and 3 are my 2 values. So they're less than 4 and odd, there's 2 values, so P odd and less than 4 equals 2 over 6, which simplifies to 1/3. So that's 1/3 or 0.3 repeating or 33.3%. So A or B is found by calculating the probability of all outcomes from each condition and then subtracting all outcomes that satisfy both conditions as shown. So probability A or B equals the probability of A plus the probability of B minus the probability of A and B. So a spinner with 8 equal sections, number 1 through 8, is spun once. What's the probability that it lands on either a number less than 3 or an even number? So we have to find the probability of it being less than 3. So there's 2 numbers that are less than 3, 1 and 2, so 2 out of 8. The probability of it being an even number, 4 over 8, and the probability of less than 3 and even. So there's 1 out of 8 selections there. So P less than 3 or even is 2 8s plus 4 8s minus 1 8 or 5 8s. Finding the probability of independent events. Independent events are a series of events in which the prior event or events do not affect the outcome of the events that follow. So for example, when you roll 2 dice, the first die does not change the outcome of the second die. So example 3, if 2 coins are flipped, I find the probability of landing on tails twice. Since each coin has a 1/2 chance of landing on tails, therefore the probability of 2 tails is 1/2 times 1/2 or 1/4. Dependent events are a series of events in which prior events affect the outcome of the events that follow. So for example, if you choose 1 card from a deck of cards and then choose a second card without replacing that first card, you change the probability of that second event. So for example, 2 cards are drawn from a standard deck of 52 playing cards. If the first card is not replaced, what is the probability of drawing a king and then a queen? So the probability of drawing a king is 4 out of 52. There's 4 different suits, so 4 kings or 1/13. And since the card is not being replaced, the probability of drawing a queen is 4 out of 51. So the probability of a king and then a queen is 1/13 times 4/51 equals 4 out of 663, which is 0.006. Example 5, 2 cards are drawn from a standard deck of 52 playing cards. If the first card is not replaced, what is the probability of drawing 2 aces? So the probability of drawing 1 ace is 1/13. And since the card is not being replaced, there's 51 decks left in the card, and there's 3 aces left. So the probability of drawing a second ace is 3/51. So I multiply 1/13 times 3/51, which gives me 3 out of 663 options equals 1 out of 221 options, which is 0.0045. So notice the number of successes changes between examples 4 and 5. In example 5, the number of successes is less 1 because one of the aces was chosen by the first event. All right, go ahead and work on the exercises below.